Okay guys, here is a quick kind of going over this worksheet real fast here. So we saw where, that's fine. We saw where our combined gas law is pressure times volume over temperature, initials, equals our final pressure times final volume over our final temperature. All right, so then we go through and we're going to read and we're going to see what all this is. So we've got, I'm just going to write it off to the side here. I have 100 milliliter bubble, so I have a V1 is 100 milliliters of hot gases at 225 degrees Celsius. Now that it needs to be in Kelvin, so that is 498 Kelvin when you add 273 to that. And it has a pressure of 1.8 atm. Okay, so let's read the rest here. What is the new volume? So I do not know my new volume of the bubble outside the volcano where the temperature is now negative 25 degrees Celsius. Now I need to add 273 to that. I gotta make it Kelvin, so that's really 248 Kelvin. And a pressure of 0.8 atm. When you write it this way, you can real quickly see if everything matches up, and my answer will be in milliliters. Okay, so now I'm just going to plug all this in. I'm going to have 1.8 times 100 divided by 498. I'm going to have 0.8. Do not know my volume. I'm going to put that over 248. Now you're going to cross multiply. So you're going to multiply 1.8 times 100 times 248. And you are going to get 44,640. I am then going to multiply this section here. And I'm going to get 398.4. And of course my B2 is still there. So I'm going to have to divide each side by 398.4. And B2 is going to equal 112 milliliters. I'm just going over this quickly because you guys should have done this. You're only going to get this video if you did your work. All right. Or I'm going to post it and you guys won't get credit. It's participation, so if I post it and you haven't turned it in, then you can't get credit for it. Be the same way in class. All right, so a scuba diver 40 feet below the ocean surface inhales, and right away I see a number, 40 feet, but it's nothing that I need. It's just giving us extra information. He's 40 feet below the ocean surface. He inhales a volume of 50 milliliters. So let's see here, V1 is going to be 50 milliliters of compressed air in a scuba tank at a pressure of 3 atm and a temperature of 8 degrees Celsius, but I have to add 273 to that to make it 281 Kelvin. What is the pressure? So I know right away, I do not know my pressure of air in the lungs if the gas expands to 150. So my volume is now 150 milliliters inside my lungs. The temperature, the new temperature is 37 degrees Celsius, so I have to add 273 to that. So that is 310 Kelvin. So all my units match up. Now I'm just going to plug them in. So I'm going to have 50 times 3 divided by 281. I'm going to have 150 times P2 over my 310. I am going to cross multiply. 50 times 3 times 310 is 46,500. And I'm going to cross multiply this second side here. 281 times 150 is 42,150. And I still don't know my pressure. So I'm going to divide by this number to get my pressure by itself. P2 equals 46,500 divided by 42,150, and that is 1.1, and it will be atm because that's what we used in our problem. Okay, if you have any questions at all, let me know, and have a great day.